Yo, 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 good morning, good evening, good day. I'm just gonna jump right in because I won't be able to go for as long as I would have liked to today as well. So, we're a little bit in a pickle because we ended on a pretty bad note yesterday. Terrain data container and all related classes has gone over a little bit of a rework, restructured both to allow for future work but also cleaned up, and hopefully this one is this one has the biggest question mark to optimize it. The problem we're having right now, though, is that the instantiation phase is extremely long and our terrain and water gets generated a little bit not as correct as we would like, and I think I know why. I'm pretty sure I know why. The worst part about all this is that it takes extremely long to instantiate, but we're gonna see if we can get to the bottom of it. Yo, what's up? I'm me. I don't even remember what I said, but she probably did. And I think the problem stems from the fact that we're now working with byte data instead of float. So anywhere where we do get data, we want to make sure that it's float we're working with and not something else. And this one is probably called from a few different places. Terrain patch. Yeah, we have this one. We have to fix this. We need to do a we have to fix that one. Yeah, we're gonna implement a get data as float. Get data as float. Although I'm not we could get the data as float between 0 and 1, but then we're gonna interpolate it again between the height range. Or we could do a remap as well. We could do a remap from, so we're working with byte data now, so it's between 0 and 255. So we could do a remap from 2 to 255 to the height range in question. I think that would be quicker. Yeah, so we could do get data remap for this one. Fluid point here. I think it's okay. Fluid point is the old one, we don't even use it. Maybe want to check this one as well, and fluid solver. That should be okay to work with bytes here as well. Let's take a look at the terrain patch first, do a proper remap, and see if we still have the extremely slow startup. I think it has something to do with the mesh generation that gets fucked up. But we'll see, we'll see. Good morning, Geralt. Hope you're having a fine Thursday so far. And good morning, Little Miss Murder. I hear you, I hear you. So previously, let's jump to this one. we knew that we would get a float here. Now we're getting ints, so we're gonna have to remap these and then recalculate mesh data here. I don't think if we put in the recalculated data here, it should be okay. So I'm gonna do this. We have a custom struct that is a range, just a min and max, random delta. What do we have more? Lerp, inverse lerp, clamp. Yeah, I think I want to implement don't we have that one? Unity math F remap. Oh, it's in mathematics. Okay. For now, I guess we could do this. Range, source range, and return lerp. Or actually, return source range dot inverse lerp value. So then we get a value between 0 and 1, and then we do return lerp. So let's say that this is the range 0 and 255. I don't know if we want to do range here actually. Do this as well. So let's say 0 and 255. We get a value that is between 0 and 1, and then we do a lerp between this range. So in terrain patch, when we calculate the heights here, height range, height multiplier, don't we have? Generate terrain data. Do we actually send it in here? Is that the first time? Yeah, we don't use it. We don't even use max dimension anymore. Good morning, Wesley. Max dimension, could this one? 1 sec. Yeah, terrain patch should know about height range, position, dimension, resolution, parent. Oh, do we actually? Yeah, we do. Okay, so when we calculate these things, we want to do get data, and here we want to do remap. Fuck, is this how I want to do it? Is this how we want to do it? Probably. It's a fucking mess. Get data. Let's see here. Get terrain patch. We want to wrap, and then terrain data get data, and we want to wrap X and Y. It's the height we want. It's byte, so we want to remap it. Luckily, I think this is the only place. Let's see here. When we actually create when we create or alter the mesh, this is the only place where we want to work with, or we need to convert from byte data to actual world height. I want to clean this up later as well. I'm questioning if this is enough to fix this issue, but we'll see. Trying to... Yep. Possibly. We'll see. Okay, progress at least, but still not entirely sure about this one. Terrain patch, water. Still extremely slow at upstart. I'm thinking that we're doing something we shouldn't be doing too many times. The question is what? Instantiate data. Call it once. We create an array of texture 2Ds. Texture index +1. If it's less than 0, return. Instantiate the first texture and then we copy it. We might as well clean this one up. So add this to the for loop here instead of relying on this one. Fluid point byte. Wonder. Okay, at least it looks correct now, but we still have an extremely slow instantiation here. By log texture index. (256 times 256). Yeah, well, I was questioning the same, Wesley. We're gonna see. Get data texture. Yeah, we're gonna try without it, but I want to do one additional fix as well. I want to do this one right here. We're gonna move this one up here and move this one in here. Data I, and we're going to start from 0. So this class is a lot more flexible now when it comes to how much data we can pack into it, or it should be. It pretty much depends on terrain data type, how many terrain data types we define. And this one should create as many textures as we need. Oh, beautiful. Yeah, it might have been a little bit over the top with the debug spam. Okay, beautiful. I think we're back. Do I want to try... Let's see here. Let's disable the water for now. Wesley, the bug is a useful tool, but spamming it in the editor costs more resources than someone might think. Yeah, definitely, especially when you do it in the place. So yesterday, let's see here, terrain data type. We have some terrain data types here, and we calculate like texture index and channel index by doing this. So it's pretty much texture index should be this divided by 4, so 0, 0, 0, 0, 1, 1, 1, 1. And channel index should be this one modulus 4. So 0, 1, 2, 3, 0, 1, yeah. And at some point yesterday, I just wanted to see that this was done in the correct way. So in get data texture, this is where we put the print. Data texture is used by data array, and data array is used by get data, and get data is used a lot. So in the initial creation, for each point in the mesh, get data is used 9 times. So yeah, 256 times 256 times 9. That is the minimum amount of times we called this one. Yeah, I fucked up. But okay, this is great. Like, if we take a look at terrain data container right now, which hopefully will be renamed soon, the underlying data is in texture 2Ds because we want to make the communication or the syncing between GPU and CPU as easy as possible. But previously we used like get pixel, set pixel, which is extremely slow. Now we work with the data directly, so most of the time it's byte-wise, or we work with the data as bytes and not color structs. I think this is really nice. But I want to see where our fluid unused 1B, unused 1A, water, here we go. So can I actually do this? Water previous, influx, nice. So we could actually set timestamps directly if we want in the data. But okay, I want to try this one. I'm a little bit afraid. Okay. Better than I expected. We got an error and... Oh, is the error just because this one was disabled? Native array has been deallocated. Terrain patch mesh 94. So when we tried to set the position here, is Yeah, it has been deallocated because it was disabled. Yes, Jack, thank you for the follow, appreciate it. So, procedural water terrain, vertical offset 0.01. This is Unity, game engine Unity, so we're writing in C#. Water, let's see what we get here. No errors, but no water either, and I think I know why. Or actually, let's see. Yeah, we're sending the wrong texture to the water shader, and that's what we want to fix. Yo, what's up, Derek? Okay, let's see here. Fluid solver. And this one is a mess. But let's see here. So when we set the final result, update all vertex data, yes. We update both. Yeah, I think it all comes down to the fact that when we do update all vertex data, we do recalculate terrain patch mesh at index, and when we do it here, we use terrain data type height here. So still some cleanup to do. So to make this work with what we have, we want to do the data index we don't care about anymore. But we want to replace it with something else. And we want to do it like, let's see here, ground mesh, water mesh, terrain, data type. Yeah, we're going to clean this one up as well. Okay, so now it's a question of... We have two different meshes here currently. The idea is to eventually only have one and alter the water based on purely on the GPU, I think, instead of doing it on the CPU. But that's like the end goal. I still want to make this work. So the question is, how do we differentiate which mesh it is we want to update? Previously we had data index, we have this quick if statement. So let's say that we have a ground mesh and we have a water mesh. We could do, like, one way to do it would be terrain patch mesh, and we say we add a primary so we could have primary type or primary data type. Primary data type, then we don't need to send it in here. Instead we do terrain patch mesh and then we do terrain patch mesh dot primary data type. And if we do it like this, we don't need to do this one still. Is this the only place we call it? I'm a little bit surprised by that. fuck are we actually doing here? Adding edges distinct to list, and then we do this. This is weird. I don't know. Feels like we have been experimenting for too long before reiterating and cleaning up. Feels like there's a lot of fragmental code laying about. Okay, so it's just the initial value that's still not entirely correct. I mean, time for some dirt puffs and water splashes, footstep collisions effect. I would love to do it, but I want to put it on hold until we get the actual water visuals in place. All in good time. Okay, so we get a freeze frame when we do this, and that's mostly because, or that's is because we update the full meshes, both of them, and we update the full collision mesh for the ground, which is rough. Yeah, sorry, I only drop in randomly and sporadically. I appreciate it. Yeah, we're pretty far off still. But believe me, I want to do some juice. Okay, so the only problem I see now is that the water mesh is at the maximum height in the beginning. We want to get that one down to the maximum, or to the bottom rather. It looks like we changed the correct texture, we altered the correct texture and so on, but when we generate the data here as well, it should be 0, so I don't really see why we're getting, although I don't see why we get it at all. Fuck. So for instance, let's see. Let's see that we do this. Yeah, when we instantiate the terrain, we create it, set layer, set material, generate terrain data, and then we generate the actual meshes. And then we update all vertex data. So when we update all vertex data, we do this. Water mesh has water as its primary data type, so we should be reading from water here. Because we do get data, we send in water, get type, or get data array. Everything should be a-okay. Could it be... When we instantiate it, we instantiate the position at... We instantiate it as at 0 as well. Could it be it? So we generate the data texture with zeros for all pixels, for all channels. Ooh. We do apply here as well. Doesn't make much sense. Unless so the water is offset a tiny bit, but not enough. Oh, height range. What is it offset by? 0.1, 2, 0.2. What am I missing? Terrain data container. This one we read. Would generate Perlin. Oh, could it be? Terrain base. We do this. So if we have initial terrain data, we do this. Let's see here. Generate terrain data, it's this one. Okay. Set material texture, yes. So we do resolution, initial. So So we do this one, and then we do terrain data height here. And we just do it for height. What happens with water then? Nothing. So terrain data container. Yeah, it's this one, isn't it? No, it's not. It's this one. Okay, so we create a new data. We never do this. Okay. I just want to try this. So if we would be doing environment, let's remove this one real quick. So we instantiate the terrain by noise. So we get it like this. And then we have the water here. Okay. And then we have the water right below this one. Okay. I think. Yeah. Okay. So if we generate by initial texture, water test. If we generate by initial texture, we don't properly instantiate the terrain data for the water, or rather, yeah, we don't properly do it. Instead we do set terrain data. Yeah, okay, so yeah, we do this one. So we create the texture, but I guess it's full white then. So that would be nice. Okay, so it's just a question of how we want to instantiate it when we call this one. So I guess we could actually do for now. So creating the water mesh or data the same as yeah, it will work for now, I think, but I gotta get to the bottom of how I want to do that. So now we should have a water mesh that is exactly the same as the ground mesh, but it's offset by 0.01 in the shader. And the end result is still, yeah, we get some formations thanks to the mesh topology. Fortunately. Ooh. Show info. Okay, this is pretty nice. Now we have it in the byte value. Pretty cool. Oops. Foliage 3 times. Yeah, that's not good. I wonder if or how I want to continue on from here. A reoccurring thing in my thought process are the normals. We're gonna have to handle the normals for the water. And I think the best way to do it would be on the GPU. So we calculate normal for the water in the GPU. So it's pretty much just recreating normals from height map. But that reintroduces the patch issue. Unfortunately, I think the water here should actually be visualized as... Oh, that's not true. We're flowing over here and down here. Yeah, that's... it's okay. No, the issue actually stems from... Oh, okay. Yeah. Okay, first of all, we want to do... I want to handle this in a better way. We want the water texture to be instantiated with zeros, definitely. I want to do one more try actually. Let's see. Environment, let's remove this one. Let's subdivide this one a bit. I don't know. Yeah, 2. Subdivision 2. Noise scale 0.05. Okay, here we should have water spreading between patches, right? Yeah. Oops. And gets fucked up. Hmm. Okay, overflowing through patches doesn't really work. It's pretty quick. It's pretty damn quick. Or was that modding Minecraft? Yes, it's supposed to be. Or it's going to be, eventually. Why did it overflow? Jesus, did we walk that far? extremely big spread. The cost of moving downwards, yeah, that's what we need to adjust. So the cost of moving downwards when we get our the initial minimas, we need to introduce that one, definitely. Sane72, thank you for the follow, appreciate it. Are we gonna get a crash soon? Too many objects spawned, possibly. But like when it comes to the algorithm working between patches, it doesn't have any problems with that, at least. We're probably gonna get nice water eventually. But the cost of moving downwards, definitely need to fix that one. How many objects do we have? $5K batches. I'm wondering, like, we could possibly get an extreme performance boost with some pre-baked data when it comes to the fluid solver. Septica, what's up? What's happening here? We're just stress testing a fluid solver, basically. cool thought it was some wave function collapse implementation. It's a custom flood fill type of algorithm with some drawbacks. Like, eventually this one is going to fill the correct area, I suppose. And the worst part is I would very much like for the player to be able to do something like this. But this is rough. Okay, so basically when we did the first pass, it found this. Endpoint. So then we fill the water with a height of this endpoint minus the fluid amount we had, I think. And going in the other direction, we don't find an endpoint for quite a while. We're starting to. I think this one has stopped. We have this one left. This would all be fine if this were something we were gonna do offline. Well, it basically, we have terrain at the bottom, and then we add water at a certain point in the terrain, and the water needs to calculate where it should flow and such. But yeah, I still have some things to define correctly here. Fuck, how do I want this to work? We're probably gonna get a okay result in the end. Revisiting nodes, probably. Fuck, it found the minimas extremely quick. A little bit worried about these pools here. So if we add water here, it should only be this one. Yeah, I think it has to do with the cost of moving downwards when finding minimas. I don't think we have any cost to that, so it's free for the water, which means that, yeah, with this type of underlying terrain, it could probably flow all the way from here to here. That's not very good. How does it look here? Are we gonna get at an end here? Okay, this one worries me a tiny bit as well. I would have loved, in fact that's probably what we're going to do next, I would have loved to see how much time this would take if we offloaded it to a second thread. We remove all visualization game objects that's being spawned and destroyed. We clean up the code so we work with less structs and classes, i.e. we optimize this solution as much as we can, and I would have loved to see just how long all of this would take if we remove every unnecessary thing. I think, or I hope, it wouldn't be too bad. Like when filling an area like this with water, I could probably... I'm okay with, we're talking like seconds. I would be okay with seconds. Have you thought about using compute shaders for the fluid simulation? Yes, sir. That would be the final speed up, I would say. And like everything is pretty much prepared for it. We're working with textures behind the scenes. So definitely. And also, like the simulation we're doing right now, we have a lot of slowdowns. That's just to make it easier to debug, but we also have like a artificial wait time in the algorithm. So yeah. I would love to dive into compute shaders. Like, I don't have that much experience with compute shaders. I have none when it comes to in relation to game development. Do have a lot of experience with like the classical type of shader, you know. Yeah, but the plan is basically to... Okay, we're now going to... I can see here that this one works. Like, we don't have any breaking issues with it. So the next step forward is probably going to be improve this one, clean it up on the CPU. The CPU implementation should be pretty straightforward. And when we have that in place, we're gonna do some performance tests for it, see how it manages when it comes to actual time. And then depending on that, we might try and implement it in compute shaders, or we might like push that into the future. Yeah, you want to get the algorithm correct first, then you can convert it to a shader. Definitely, 100%. 100%. Like everything is easier to do on the CPU, I would say. But look at this. So like every box here is an actual monobehavior game object when we're debugging it like this. So transform, cube, mesh render, they are not instanced. And yeah, we are creating and deleting or destroying multiple of those every step. But like when I look at this, like I can see it converging towards an acceptable result for what we actually fed it. So no complaints there. You could also think like I'm trying to think about it from a gameplay perspective as well, And you can also think about it like, if the player want to fill this big of an area with water, we might even... Okay, so I have this dream that it should be in real time, basically. But that might not be the case with areas as big as this one. So you might even offload the algorithm work during the night. So like when the player ends a day and starts... When the player ends a day, that's when we do this run. And then the next morning show the result. But that's not as clean. What's up, Harukanen? Hope your foot is alright. Did you go into operation, by the way? And yes, I do. I mean, especially when you're creating objects, the computer can't do that. Yes, exactly. Like, when we experimented with this algorithm, I wanted like instant feedback on what it was doing. And I wouldn't really be able to get that in as good of a way as this. And also, I'm a bit shaky going into compute shaders. Yeah, this I'm not entirely okay with. Yes, I mean, this is just one coroutine, and we have like artificial wait times between each spawn and stuff like that. So yeah, this is slowed down as way slowed down. Harukanen was still too much swelling this Monday, so going in today to check the swelling again, and hopefully surgery tomorrow or next week. Damn. And I know sometimes when there's a lot of swelling, they have the option to draw blood to make the swelling go down. That was never an option. That seemed to be an okay way to go. It's not time dependent, right? Nah, it's not crucial, I would say. Especially not a big area like this. The time. I have a lot of decisions to make, it feels like. Yeah, it's not critical, it's not critical. This one I'm also a little bit worried about. Don't early optimize. Yeah, that's definitely something I want to avoid doing too much of. But like right now, I still see a few things I'm not too happy with. Are we done? I was still working a little bit over here. And now we do this, I hoped. I kind of know that is really a bad idea. Would probably be an emergency situation to do that. Okay, okay. Okay, we're getting closer. Revisiting nodes here. doesn't sit right with me, but there exist some cases where that has to happen. I just wonder if this is one of those. Like, what the hell is it doing here? I can't imagine it being more water here. Or are we not removing nodes in the correct way? Ah, we still have some patch issues, I see. Yeah, we do. Yeah, we do. Or the water has patch issues, that is. I would love for the player, if the player wants his or her garden to be a swamp, I want to let them. Like, this is something I would like to allow for. Patch issue here, though. That's not good. What 156? What 156? 130, 53. Yes. So we have. Ooh, that might actually be a cause for the duplication as well. So this one has a water value of 123. This one has of 128. I think I might know why. Yeah, I think I might know why. Okay, so there's a little bit of a hole in the algorithm that we need to solve, and it has to do with when walking from one patch to another. Basically, two neighboring points in two neighboring patches should represent the same value. Our fluid solver doesn't take that into account, so while walking from one pixel to another, the fluid solver doesn't actually walk one step, or it shouldn't walk one step, but it does. And that's why we get a little bit of a mess there. What's up, Smack? GDs, water indeed. Would love to continue this, but now I have some data to think about and how to continue from this. Like, it looks good, but I gotta run. We'll be back tomorrow, hopefully improve it a bit. Thank you so much for watching, everybody. Appreciate it. Get well soon, Harukanan, and have a great rest of the day, everybody. Peace.